Welcome to my YouTube channel, and we're going to continue from where we stopped. So today we want to discuss about electron, volt, and kinetic energy. Right, so I've put down some short notes. In an atomic theory, the energy of an electron is expressed in joule. We all know energy is expressed in joule. The unit of energy is joules or electron volts. Right. An electron volt is the energy acquired by an electron in falling freely through a potential difference of 1 volt. Therefore, 1 electron volt equal 1.6 times 10 to the power of minus 19 joule. An electron volt is the energy acquired by an electron in falling freely through a potential difference of 1 volt. Emitted electrons are accelerated through a potential difference V and acquires a potential energy EV. Now, this potential energy that is acquired is now converted into kinetic energy, and the electron finally acquires a velocity. Now, kinetic energy has to do with energy in motion, so it is converted to kinetic energy. So therefore, there is going to be a velocity. Now, this process is expressed as follows. I will be writing down the formula we'll be using to solve problem that has to do with electron volts and kinetic energy. Alright, so it will be EV. This is the electron volts, this is the potential energy. It's converted to kinetic energy. So let's write that of kinetic energy. We know that it's half mv squared. But right now we are talking about electron. So we'll be using the mass of an electron. Alright. So EV, from our previous video, you know that this is the same thing as this is the kinetic energy. And in what we'll be discussing so far, I told you from the previous video that energy is equal to Planck constant times frequency. So it means this can be expressed as EV is equal to HF, which is the same thing as H over C lambda. All these have been discussed in the previous video. So if you've not watched that, please go and watch that. Alright, so let me, this is the electron and it's a constant, which is 1.6 times 10 to the power of minus 19. Why this is the accelerated voltage or the potential difference, this big V. Let me put this one as small v, so I will not be confused. Okay, so MA is mass of an electron, and it's also a constant, which is 9.1 times 10 to the power of minus 34 kilogram. Okay, and this is velocity. All right, we already know this. H means a constant. It's a constant 6.63 times 10 to the power of minus 34 joule seconds. And this is frequency. C is the speed of light. The speed of light is 3.0 times 10 to the power of 8 meter per second. Alright, having said all that, let's solve this question. A 500 kilovolts, that is capital letter V, equal to 50 kilovolts, which is same thing as 5.0 times 10 to the power of 5 volts. If you don't know how to convert, please watch my video on conversion, because kilo is 10 to the power of 3, and I just took this decimal point two places. So 2 plus 3 is equal to 5. Alright. It's applied across an X-ray tube. Now, they said we should calculate the maximum velocity, that's 1 meter v, of the electron produced. We are given constant. There's no need to write the constant again. We're given constant. These are the constant. So now we have our potential difference. Now we have velocity. Now I gave you 3 formulas: 1, 2, 3. Which one are we going to pick? Okay, I guess you are saying the first one because we can see that there is velocity there. So what we have is EV equal half MEV squared. So I'm going to make V squared. V the subject of formula. How do we do that? This will go I cross multiply. So I'll be having 2EV equal to MEV squared over ME over ME. This takes away this. Now I'm left with V squared equal to 2EV over ME. Now how do I take away square? I take the square root. The square root of both sides. So this square cancels this. What I'm left with is V equal to the square root of 2EV over ME. So we're making use of this formula. Now, there are a lot of things that are going to happen here. Now, you can take your advanced calculator, let's say like Casio, natural display, and then punch all the values, and it's going to give you the answer direct. But right now, we have external bodies that do not permit this calculator. Exam bodies like JAM, you can't punch this direct. Even WIEC, you can't punch this direct. So I want you to pay attention to the way I'm going to solve this mathematical problem, because everything from here, it's pure maths. Okay, let's begin. I'm going to take a very, very big square root, and this is 2 times, what is our electron? Our electron is 1.6 times 10 to the power of minus 19. Okay, and then our V, which is the potential difference, is 5.0 times 10 to the power of 5. Divided by our electron, mass of our electron is 9.1 times 10 to the power of minus 34. Okay, let me borrow this side of the board. Okay, now this is what you do. Pick every number and leave that which is 10. I repeat, pick every number and leave that which is 10. I'll pick 2, I'll pick 1.6, I'll pick 5.0, I'll pick 9.1. So it now becomes square root of 2 times 1.6 times 5.0 divided by 9.1 times, now everything that is 10, I'm going to now treat them. Everything that is 10. Now everything that is 10 now is 10 to the power of minus 19. And remember that multiplication means addition plus 5. Now division means subtraction. Minus, what is here? Minus 34. Now please, I want you to always take note of minus. Minus is a very, as little as it is, it's very, very, very dangerous. Okay, so division means minus. What is here is minus 34. So don't do the mistake of just writing minus 34 straight. Okay, so what is 2? 2 times 5 is 10. 10 times 1.6 becomes 16. 16 divided by 9.1 is 1.758 times, and let's do this, 10 to the power of, now we have minus 19 plus 5 minus minus. So what we are having here is minus minus, negative negative is addition. So 34 plus 5 is 39 minus 19. Everything here is 20. And then what we're going to be having now will be the sorry. Now the square root of 1 point. Let me split this. So we have square root of 1.758 times square root of 10 to the power of 20. And then square root of this is 1.33. Okay, times. Now this is our focus. These are focus. Let me explain some mathematical term here. Now this is pure indices. Now when you see square root is the same thing as a to the power of 1 over 2. I just use a as an example. So the square root is the same thing as raised to the power of 1 over 2. Now at this junction, what I'll be having will be 10 to the power of 20 times 1 over 2. So it's going to be 2 years here, 10. So it will be 10 to the power of 10. So here will be 10 to the power of 10 meter per second, because we're looking for velocity. And okay, so that's all about this question, but I still want to say some things. Now, the reason why I want us to use this method, let's say this is not part of the question. Let's just giving you some bonus tip. Let's say we have 0.4 times 10 to the power of minus 7. Now, the idea of using this is that the value here must be an even number, not an odd number. Why? Because this square root is the same thing as to the power of 1 over 2. So we want to have a value that will be divisible by 2. And 7 is not. Values that will be divisible by 2 at this range will be minus 6 or minus 8. So now we are having 0.4. Now let me split it. We have square root of 0.4. Should the case you have a value that is not 20, this one was just very, very straightforward, times square root of 10 to the power of minus 7. I want us to pay attention. Now, this I can find the power here. I can find the square root here. But this I'll be having 7 over 2. Do you see where I'm going to now? So the best thing now is to convert this minus 7 to minus 8. How do we do it? This is it. It's just standard form. Maybe I'm going to do a video on standard form. Yeah, a separate video on that. This will now be square root of, if I take this decimal point to this place, this will be reducing by 1. Listen to me. If I take it to the right, it will be reducing by 1. If I take it to the left, it will be increasing by 1. So if I'm taking this to the right, it now becomes 4 times 10 to the power of, I say it will be reducing by 1. So it means if I am going towards the right, I'll be subtracting. If I'm going towards the left, I'll be adding. So minus 7 minus 1 now become minus 8. Can you see how straightforward this is? So I'll be having square root of 4 times square root of 10 to the power of minus 8. Square root of 4 is what? 2. Remember, this is the same thing as 10 to the power of minus 8 times, what's the meaning of square root? 1 over 2. That's correct. So 2 here 1, 2 here 4. So it will now be 2 times 10 to the power of minus 4. Should in case what we are having here is not an even number, it's an odd number, so now we take it, you can take it towards the right, and then this will become minus 6. Now minus 6 divided by 2, which will be minus 3. So that's the idea concerning this. Okay, so I hope you've copied that. Yeah, you can pause the video and copy that. Alright, so let's dive into this question. Okay, so the potential difference between the cathode and the target of an X-ray tube is, now potential difference, that big V is 5.00 times 10 to the power of 4 volts. Okay, and the current in the tube, current is 2.00 times 10 to the power of minus 2 ampere. Given that, listen, given that only 1%, please take note of this, of the total energy supply is emitted as X radiation, determine the maximum frequency of the emitted radiation. We're giving Planck constant, taking this charge. You can write that. Okay, so now back to this. I want you to pause the video. 1, 2, 3. What formula should we use? Okay, alright, you are very, very correct. It is the third one, because now we are asked to find the frequency. Is frequency here? No. Is frequency here? No. Frequency is here. Alright, so we're using this and this. Alright, what if wavelength was given? We'll be using this and this. Okay, so we have E B equal H F. Now we are looking for our frequency. So to calculate, to find the frequency now, it will be frequency equal electron volts over the Planck constant. Now, this is the formula, right? But there is something. They said 1% of the total energy. If I say 10% of A, what is the meaning of 10% of A? It means, alright, 10% of, in mathematics, means what? Times A. Alright, so using this expression, we're going to dive here right here. Now, 1% of the total energy. So what we have here to be times 1%. And 1% is the same thing as 1 over 100, which is the same thing as 0.71. What I'm trying to say is 1%, same thing as 1 over 100, which is the same thing as 0.01, which is the same thing as 10 to the power of minus 2. So, I would love to use 10 to the power of minus 2. It makes my calculation very, very, very straightforward. Okay, now let's substitute each value. E is the charge, 1.6 times 10 to the power of minus 19 times potential difference is 5 times 10 to the power of 4 times 10 to the power of minus 2 over, I'm sorry, I didn't put 0.00, okay? So H is the Planck constant, which is 6.63 times 10 to the power of minus 34. Okay, right. What should we do? Yeah, you're very, very correct. Let's pick everything that is not 10. 1.6 times 5 over 6.63 times. Now let's focus on the 10. 10 to the power of minus 19. Multiplication means what? Addition. That's correct. Plus 4. Multiplication means what? Addition. That's correct. Minus 2. Division means what? Subtraction. And then we have minus 34. Okay.
So 1.6 times 5 divided by 6.63 is 1.21, approximately 1.21 times 10 to the power of. Okay, let's do this. Minus 19 plus 4 should give us minus 15. Minus 15 plus minus is, okay, let's do this. Positive, positive is what? Positive. Negative, negative is what? Positive. Positive, negative is what? Negative. Negative, positive is negative. So people will say, the friend of my friend is my friend. The enemy of my enemy is my enemy. The friend of my enemy is my enemy. The enemy of my friend is my enemy. So that's all like what we just say now. So plus minus is minus. Alright, let's start again. Minus 19 plus 4 is minus 15. Minus 15 minus 2 is minus 17. And then we have minus 17 plus 34 is actually 17. So 17. Is anything missing here? Yes, you're very, very correct. You're saying, Mive, there should be the unit, which is what? Frequency. And the unit is hours. What is the real unit for frequency? Per seconds. Okay. So that's all about the first part of the question. Now let's go to the second part of the question. Now the second part said that we should find the rate at which it is removed from the target in order to keep it at steady temperature. We should find the rate. Okay, so finding the rate. Now let's discuss a little bit. Now, what's the meaning of rate? I want you to put it straight to you. In physics, when you hear the word rate, it means over time. What is the rate of this marker? Is this marker divided by time? What's the rate of this bottle? Is this bottle divided by time? So now you're asking for the rate at which the heat is removed from the target in order to keep it at steady temperature. Now for it to remove, we're talking about the energy. Now what is the rate of energy? The rate of energy is energy over time. And please, what is energy over time? Yeah, correct. Power. So power is energy. Power is the rate of work. And work is the same thing as energy. So what we are looking for is power. And then P equal to energy over time. Now, the question now is, do we have the energy? Yes. Is time given to us in the question? No. So what other formula will relate to power? We have that which is called IV. Current times voltage. Alright, so current times voltage is the same thing as power. I used to tell my students, when you go to a show, there's this special place reserved for people. We call it the VIP. So just flip it. It's now PIP. And just put equal to. So this is high times V. Current times voltage. Okay, that's my theory. Alright. Okay, let's continue. Now the question now is, we also have other formulas for power. If we use this, the Ohm's law, let's say it's V is equals to IR. So let us chip this into the video. Instead of writing V is equal to IR. So instead of writing V here, just change this V. It now becomes I times IR. This IR is actually this V. So it's now become I squared R. So this is another formula for power. Another formula for power is, if I make I the subject of formula here, over R, this cancels this. I is equals to V over R. So instead of writing high here, I'll just write V over R times V. V times V is
V squared over R. Okay, that's by the way. Okay, so now we have IV. The reason why we're going with this is because current is given to us in the question. If it was another thing that was given to us as resistor, then we'll have to look for the formula that fits in with resistor. Okay, so the rate at which the heat is removed from the target in order to keep it at steady temperature. Now, the issue now is 1% of the total energy supply is emitted. So if you want to find that which is removed, it will now be the energy now. You know, this is 1% of the energy. Now, that which is removed will now be the sum of all energy is what? Sorry, the sum of all percentage is what? 100. So it's now 100 minus 1 percentage of energy. Okay? Okay? If I say 20%, what is the remaining? Simple, 80. Because the sum of all percentage is 100. So if 1% of the total energy supply is emitted as X radiation, and we have to find the rate at which the heat is removed from the target in order to keep it at steady temperature. So it's now the remaining part, which will be 100 minus 1. So what we have here is 100 minus 1 percentage. Okay. So what is high? High is our current, which is 2.00 times 10 to the power minus 2 times what is our voltage? Our voltage is this 5.00 times 10 to the power 4 times 99%, which is 99 over 100. Okay. Do you want us to go like this? I don't want us to go like this. I don't know why. 99 over 100 is same thing as 99 times 10 to the power minus 2. I love using this standard form. Like it makes work very, very easy. So we have 2 here, we have 5. Okay, you're correct. 2.00 times 5.00 times 99 times 10 to the power minus 2. Multiplication means addition. Multiplication means addition. Okay. So 2 times 5 is 10. 10 times 99 is 990 times minus 2 plus 4 is 2. 2 minus 2 is 0. So we're having 10 to the power of 0. Anything to the power of 0 is what? 1. Okay. So everything is 10 to the power of 0, which is the same thing as 990 times 1, which is equal to 990. What is the unit for power? Watt. Okay, so that's the end of this video. We're going to meet in the next class and look at the next subtopic. Thank you very much.